Hi everybody, and thank you for registering to this webinar on deploying an R procedure in Excel using the XLSTAT-R interface. So I assume that if you have registered to this webinar, it's because you are already familiar with R and you have already coded a bit in R. So XLSTAT-R is a platform that will help you design dialog boxes within Excel, dialog boxes that will help you input your data from Excel and send them in the form of arguments or of data set to R functions, then take back the outputs from the R functions and display them within Excel. We'll see what, for those of you who don't know XLSTAT, you will see how the software looks like. And my name is Jean-Paul Maalouf. I'm a statistical consultant at XLSTAT. You are able to ask me questions all along the webinar. So you have a chatting window in which you can enter your questions. I'll run a Q&A, questions and answer session at the end of the webinar during the last 10 minutes. You have 3 handouts that you can download in the handouts section. So you have the presentation slides, you have the data set we're going to use, which is a data set on a chocolate survey. And you also have a Word document that contains some XML code, the XML code that we're going to illustrate. I apologize, I was unable to transfer an XML file to the webinar platform. It doesn't accept this kind of file, so I just pasted the code in a Word document. You can simply copy and paste the code in your favorite code editing platform to play around with it. I personally use Notepad++ usually, as you will see. So as I was saying before, there will be a recording of this webinar made available online, and you will receive the link probably tomorrow, I think, or on Monday maximum. So let's go. First, I start with a plan. I will say what is R, then what is XLSTAT, and what is XLSTAT-R. Then we will see how we'll use XLSTAT-R, which establishes a link between R and Excel, how we will use XLSTAT-R to make the PAM function available in Excel or in an Excel dialog box. The PAM function is the partitioning around medoids function available in the cluster package in R. So we'll see how we'll set up the inputs, how we'll write up the R code for computation, and how we'll specify the outputs to display. And at last, we'll see how to add a chart option. So what is R? I think that all of you are familiar with R. It's a free software environment for statistical computing and graphics. I just pasted this definition from the R website, which you can access here. So R has, as you may already know, unlimited possibilities. I think today we have maybe more than 100,000 functions in R, maybe many more, I'm not sure. And all these functions, you can use them within large procedures that you can execute on your data. So there are basically unlimited possibilities, but users need to know how to code. So this may not be a problem for you or for me, but there are many statistical practitioners or even practitioners who just temporarily need to use statistics, who don't want to learn how to code in order to run their tests or their models or the statistical stuff. So this is one of the problems from R. You need to know how to code. Now, what is XLSTAT? XLSTAT instead is a user-friendly statistical add-on software that works in Microsoft Excel. Actually, it's more convenient to use as everything happens within Excel. So Excel, which is an environment that most of statistical practitioners know how to manipulate. Let me tell you a brief historical overview of XLSTAT before switching to XLSTAT-R. So everything started in 1993, the development. And then in 2000, the Addinsoft company, which currently develops XLSTAT, was created. And there have been many major developments since then until 2017. It was last December, actually. it's very recent. We have created the R integration in XLSTAT or in Excel. So now we're going to investigate this part of the timeline. In a few numbers, XLSTAT holds more than 200 statistical features, and today with XLSTAT-R we have virtually unlimited features. We are 24 employees at your service. Last year we've had more than 100,000 users. We have more than 10,000 downloads a month on the website of the software. So XLSTAT proposes a very user-friendly way to tackle data analysis, as everything happens in the familiar environment of Excel, as I told you. So let me show you how it looks like. This is Excel, and this is a data set. It corresponds to a survey of chocolate consumers. We basically asked several consumers in rows to what extent are they loyal to brands, are they sensitive to prices, are they fond of online buying, and to what extent do they prefer bitter chocolate, frozen chocolate, or crunchy chocolate. Those are scores from 1 to 10, and the data were made up. XLSTAT appears in the form of an additional tab within Excel. There it is. And it holds many menus in which you can find statistical features that are developed by our team. So we have modeling data, we have features for machine learning, naive Bayes, we have random forests, we have tests, correlation, chi-square, parametric, non-parametric, and you also have advanced features that are more field-oriented. So for example, we have many features for sensory data analysis, for marketing, conjoint analysis. We have tools for time series analysis, SPC, design of experiments, survival analysis, and you also have structural equation modeling. But now, let me show you just how a basic XLSTAT feature works. So I will just take analyzing data and select PCA, or principal component analysis. I assume that most of you are familiar with this method. So I click on it, and typically you have a dialog box that appears, a user-friendly dialog box, and this dialog box is made out of several tabs. So you have general tab, options tab, supplementary data, data options, outputs, and charts, and those tabs, configuration of those tabs depends on the feature you are using. Even may have sub-tabs within the same tab. So you have within charts, you have variables, observations, biplots, and bootstrap charts. You can enter all the information you want within this dialog box. So here you have a data field to select the data you want to run your PCA on, like this, for example. You can add observation labels here, like this. You can go for a correlation PCA or a covariance-based PCA. And there's a very important option here I'd like to talk to you about. It's the variable labels option. Actually, it's a very small detail here, but it's important for later. So variables labels, you need to activate it or deactivate it according to if you are selecting the labels of the variables within your data. So here it is the case. When I selected my variables, I selected the first row, which corresponds to the labels of my data. So I need to activate this option so that XLSTAT knows that the real data start on row 2. So I click OK, and there we go. I select my axis, I click Done. And as you can see, the outputs or the results appear in a new Excel spreadsheet. So here we have results on the eigenvalues associated to each axis, and those results you can customize them using Excel. You can do whatever you want, and you can save the outputs and send them over to your colleagues. And here you can use the Excel charts options to customize your charts. You can change the titles and everything. So you have a very extensive outputs that can be reached without needing to code. I have my correlation circle here. Then I have squared cosines of my variables. I have my observations chart here. And the bootstrap chart with the convex hulls. And at last, the biplots. And many more information that you can customize as you like. Okay, so now let's switch to the core part of the webinar. We're going to talk about XLSTAT-R, which is part of this menu. So I'll click on this menu and let you just take a look at this list. I don't know if you're familiar with those labels: vegan, viz, stats, PLM, Cohonen, neural net. I don't know if they ring a bell or something. So those are very famous package names from R. For example, Cohonen allows you to run self-organizing maps, or PLM allows you to run panel regression. You have GLMNet that lets you run ridge regression or lasso or elastic net. So those are packages in which you can find some features, some R features. Neural net lets you run neural networks. So the neural net package includes a neural net function, allowing you to run neural networks in R. So I will show you how this looks like. So this is basically a dialog box that is typical of XLSTAT. But the only thing that it does is that it lets you capture the data in Excel as well as information, and then transfer all these data and information to R. Then R uses the neural net function to compute outputs before sending them back to XLSTAT-R that displays them in Excel. So I will show you quickly an example. Here I take as a dependent variable brand loyalty, for example, that I want to explain with those three variables. The options, there are many things I can play around with. So all of these information will be, all of these numbers will be objects that will be transferred to R. So I will remove the interactions, I don't need those. I can also add data on which you want to predict. There are several ways to handle missing data. And there are outputs and charts. So if I click OK, there we go. Once again, I have typical outputs from XLSTAT, but that are computed in R. Weights, everything. We have charts, and we have typical neural network charts also that were generated from R and imported in Excel. So this can be very convenient for practitioners who want to use R procedures but who are unable to code or who don't want to learn how to code and want to quickly be operational on their data. So how do these functions actually work? Behind each of these functions, you have an XML file. XML is extendable markup language. It's a coding language that defines how the dialog box is designed, what are the inputs that are sent to R, what is the R code that is run, and what are the outputs that are extracted from the analysis in order to be displayed in Excel as outputs every time you click on OK. All of these XML files associated to these functions can be accessed in this folder. So here, if I click on Open the XLSTAT-R folder, I have one folder per submenu. For example, if I take rfit, I have the XML file associated to rfit, the rfit function. Neural net, here I have the XML file that generates the neural net dialog box. So these XML files, you can edit them as you want in order to transform the functions as you like, adding R code or adding options in dialog boxes. So you're free to use them as you like, and it's very flexible. So now we got here. I think you figured this out. XLSTAT-R has two audiences. First of all, the coders who are able to write XML code, extensible markup language, and R code to set up XLSTAT-R dialog boxes. Second audience is practitioners who simply take advantage of these dialog boxes that are designed by coders without even needing to code. This webinar here is intended for the coders audience. So we'll see how to implement a function in XML code. Now, practitioners can be either your colleagues, your statistics colleagues, or your partners, or even your clients who need to access specific R procedures from Excel, or your students, or simply yourselves if you have complex procedures you don't want to execute every time and to import and export data and struggle with this every time you execute them. You can simply code them in an XLSTAT-R dialog box and let it do the job every time. If you click on this link, you will reach some documentation on the web around XLSTAT-R. You have articles here on how to install XLSTAT-R and how to get started with it. Here you have an interesting article on how to deploy a simple function in Excel. It's simple, but it's very detailed. It's a bit long because it goes through a lot of details, so it's interesting if you want to really to customize in a very detailed way your XLSTAT-R procedure. Then this article is also very important. It's the documentation that compiles all of the XLSTAT-R XML code specification. So as you will see, the XML code associated to XLSTAT-R is quite straightforward, and here you have all the nodes and the attributes that you can use. So what's our goal today? We want to make the PAM, or partitioning around medoids, R function available in Excel. So PAM is part of the cluster package. It's an unsupervised machine learning method used for classification. So what is classification, or clustering, or segmentation? Classification is when you have a group of observations or of individuals, a group that you want to segment or to split into several subgroups with homogeneous observations inside. One of the most popular tools of unsupervised machine learning for classification is k-means. But PAM is considered as a more robust version of k-means, and there's another very important advantage of PAM over k-means, that it allows for missing data. So this procedure can ignore missing data and perform classification. How will we proceed? Well, first, we'll simply open an XML code template. Then we will specify what we want to enter as inputs in the dialog box. Then we will write up the intelligence behind, intelligence being the R code that will be run on the inputs. Then we will specify the outputs and add a chart option. So here you have the same articles I mentioned before. You can access them from here also. So let's get going. So here I am in XLSTAT. How can I start a new template? I will simply click here and click on Open an XML template. It's very simple. XLSTAT automatically opens the template in a notepad file, a text file. I propose that you copy and you paste this code in a code editor like Notepad++. I personally use Notepad++, which is very convenient because it includes many languages you can play around with, including R. So this is a typical XLSTAT-R function template. The XML code includes several parts which are called nodes. It's a bit similar to HTML. So the nodes are introduced with this sign here, and they are closed with the opposite sign. This is the method node. The method node is the root structure, will be the root structure of your procedure. And this node includes many subnodes. So you can nest nodes within one another. And nodes contain attributes such as text or data structure or function. An XLSTAT-R XML template is divided into several parts. First of all, we have this part that will contain some basic information about your functions, such as the packages we need to load, the short description, the author of the function, and your name, yourself, and then the day you created the template, the day you modified it, the version of the package you are using, and many other things. So this is the first part. Second part is this one, where you start designing your user interface. The user interface is simply the dialog box. So here, as you can see, for each tab, here the general tab, you have a subsection. Here you have some space for the options tab. You can customize your missing data tab, your outputs tab, and your charts tab. And within each tab, you can insert many elements, and including spacers, so that elements don't go one over another. The next column node allows to jump from the left of the dialog box to the right of the dialog box. The spacer node allows to provide or to include some vertical space between two adjacent elements. And here there's a small node that corresponds to an automatic option in XLSTAT, which correspond to this variable labels options that I showed you before. It's an option which corresponds to a checkbox that lets you configure whether you are selecting your data with their labels or just selecting your data. So it can be included or excluded. So first part, description. Second part, dialog box. Third part, the results we want out of R. For each result, you can insert one line of code, and each section or line of code you can put inside the data frame as well as a chart. And at last, we have the R code. Usually, what I like to do is to start with all the description stuff here, then switch to the inputs, so the user interface. Then, once I have the inputs, what's the most logic thing to do is to use these inputs to write up the R code. And as soon as I write the code, I can extract the results in this section, and the job is done. But you can have your own procedure if you like, but this is the way I work. So let's get started. I will start by filling out these things. So my method name, I will call it partitioning around methods, like this. Then here there's an attribute which is quite important, the data structure. It's an important attribute for XLSTAT-R. Actually, XLSTAT-R handles two types of data inputs. Can either have data that can be split into two parts, a dependent variables part and an independent or predictor variables part. And this data structure is called model in XLSTAT-R. So it's the kind of data that can generate formula objects in R. And all the other functions, you can use simply data to the data structure to write them. And this is the case of the PAM function, as in PAM you only need to import one single data set which you want to cluster. So I will select data here. Then the function, how would I like to call the function? Call it PAM, for example. I will add it in a submenu in the Excel ribbon. Usually I like to enter the typical package I'm using, so cluster. What are the packages you need to load in order to let your procedure work? Here we only have one single package to load, which is cluster. If I had several packages, I could have added them like this, for example, like, I don't know, like this, separated with commas. You can add a family of methods, I don't know, supervised machine learning. No, it's unsupervised, sorry. And there are many other information that could be entered. And here my name is Jean-Paul Maalouf. I can extract the R function authors from the help of the help article of the associated functions. And I can also paste a description that specifies how the method works. So now I won't waste time and fill out all of these things. I have a template that's already filled out, which is here. I'll just copy and paste everything and get going. Well, simply call it partitioning around medoids 1 because the first one is already called partitioning around medoids. Okay, here I will save my XML template and I will see how it appears in XLSTAT. Here I will open XLSTAT-R. I will just refresh and then go to cluster, and here we go. There's my new feature. If I click on it, I get a dialog box with this typical option here I was telling you about, the variable labels option. But it's empty here. I still need to configure things in here. The options, missing data, and the outputs. So let's go. We'll start with the general tab. What's the most important thing to have or to provide the R function with in order to perform the classification? The most important thing is the data. So we'll start a node which corresponds to a data field, a data selection node. And typically in XLSTAT-R, this is called data field. So all of these nodes, as I told you, are well documented in the document I showed you on the internet. The data field node can contain several attributes. I'll just fill out the most important ones. First, the tag, which is called text. In the tag, I will insert, say, observation to cluster. And what's very important, what's the other thing which is very important within this data field node? We need to create some kind of an object in R in which we will inject or will store the inputs that are selected in this data field. So we'll use something called, an attribute called rname, and we will call it, say, I don't know, data. So here, XLSTAT-R will take the data selected in this field and send it over to R within an object named data. So I think you started to guess that this object, data, will be used in the R code right below here. So what other important things should we consider in a clustering problem? How about we check the PAM help documentation? There it is. So this is how the function is written. We have several arguments. We've just configured the X argument, which is the input data. There's another super important argument, which is the number of clusters that we want, which is K. That should be a positive integer specifying the number of clusters, and which should be less than the number of observations, of course. So let's insert the K input of information in our dialog box. So I propose that I put it right under the variable headers option. So I put some space between both, and I use the input node. So text, for example, I take number of clusters. And one important thing is that you should say that it's an integer, so that if somebody enters a double or a string, XLSTAT provides an error saying that no, it should be an integer. Then what's very important here, the rname attribute. So in what object do we want to store our number of clusters? Let's name our object K simply. So let's see how our dialog box looks like so far. I'll refresh and then open. It's right here, right here. See, we have an observations to cluster field here in which we can select data like this. And you have a number of clusters that you can configure as we want. We can add 4 clusters or the important thing is to enter an integer. There's something interesting also in this input section is that you can enter default values. So let's say that the default number of clusters will be 3. Then, are there any other interesting things to enter? Let us see right here. Basically, all of these things could be interesting to configure in the dialog box, but maybe all the options are not really necessary for the practitioners. I think the metric argument is quite interesting. The metric argument allows you to choose among several metrics to compute between the observations. Here we only have Euclidean and Manhattan metrics. So how can we let the user choose among a list of several elements? Here we only have 2 within a dialog box. How about designing a combo box, which is an arrow? If you click on it, you will have all the elements of the list, and the user will be able to choose the element he wants. So the combo box is a bit long to type by hand, but I'm just going to paste it from the original partitioning around Medoid's XML template. So just paste it here. And there we go. In the options tab, I have added a combo box, which is associated to a label, metric, and an R name, which is also called metric. So you can call it whatever you want. And the combo box node includes several subnodes, as many subnodes as there are elements in the list. Here we only have 2 elements, so I have added 2 items. So one which is called Euclidean and associated to the R name Euclidean, and another one which is called Manhattan. If the user chooses Manhattan, for example, the information that will be sent to R is that the metric object will contain the Manhattan string. Here you can select a default value for the combo box. 0 corresponds to the first element of the list. So here if I save and I go back to my XLSTAT-R interface, you refresh first. There we go. I have a combo box in which I can select many elements of a list. Then the missing tab. The missing tab includes several options that are dealt by XLSTAT to handle missing data. So you can ask XLSTAT to stop the computation or to block the import to R if it detects missing data. So if you choose the refuse option, you can ask XLSTAT also to remove all the observations that include missing data before handing them to R. You can also ask XLSTAT to replace the missing data by the mean, the mode, or by a KNN procedure. There's an option that is not here, but that is very important for us, for the PAM feature at least. It's the ignore option. So XLSTAT can also simply ignore the missing data and send the data to R without doing anything. This is important for PAM. This is one of the main interests, the main advantages of PAM. It's that it allows for missing data. So the ignore option is very important. And you can even set a default value. I'll set it to ignore. Okay, for outputs and charts, XLSTAT-R proposes automatic procedures that will extract outputs and charts from the results section. So we won't be touching this for now. Now that we have all the inputs, let's write down the R code. The R code is made out of a node, which is R script, and the R script node includes subnodes, which are script lines. There's an attribute within the R script node, which is replace by value. It's the equivalent of replace within script line. Well, I suggest, at least for this webinar, to use false, because I think it's a bit more intuitive to understand. But I won't enter into the details of the difference between replace by value equal false or true. If you want to understand the details, just refer to the documentation or to this tutorial on how to deploy a function in XLSTAT, an R function in XLSTAT. There is a complete explanation on the difference between both. So here we'll simply use this one. So here for each line of code, I need to create one row. And there's a convention in XLSTAT-R. All your results should be stored in an object named results. So here I'll simply need to write down my function. What should I put in my arguments? Let me see. What are the main arguments I defined? I defined x, k, and metric. So x should be fed with the data object. The data object that, I remind you, was set up in the inputs here. This is where we capture the data. Then k, the k argument should be fed with the k object. K is the number of clusters. And the metric argument contains what is inside the metric object. So here we go. We have our results. Next step is to define what to extract from these results to display them in Excel. So what can we extract out of a clustering procedure? What's the most important thing to extract? The most important thing to extract is the cluster membership of each observation. I think you agree with me. So how can we extract cluster membership from this function? Well, it's very simple. Let's simply execute the example here in R and see if we can do something. Like this. So this is the R console. And this object contains the results of the PAM function. So let me see how it looks like. What we need is this clustering vector. This is the cluster affiliation of each observation. And I think this is part of the clustering sub-object. Let me see. So PAM x dollar clustering. Yes, that's it. So now I'm happy. I have the output I want to extract from R. The only condition to be able to extract an output from R in XLSTAT-R, at least for now, is that this output should have the form of a data frame. You cannot use outputs that are not data frames in XLSTAT-R today, at least. So you should be transforming this vector here into a data frame before importing it back again to XLSTAT. So I write this down in a new script line. So results clustering. So this is my membership vector equals as data frame results clustering. Okay. So now we have the results we want to display. So I remind you that all the results you want to display should be included within the results object. Now that we've written the intelligence, last step is to write down the outputs. And the outputs, here we only have one. It's the clustering membership. And everything should be configured here in the results. So we may remove all of these things which are a bit complicated. I'll only use two attributes, the text attribute. So clustering membership, which corresponds to an R name clustering. This should be one of the sub-objects included in results. So now basically my dialog box should be working in a very basic way. Let me go to XLSTAT and see if it works. Like this. Okay, I have a default number of clusters, which is 3. I can take the distance I want. I can ask to ignore missing data. And here in the outputs, XLSTAT-R automatically included my first result, which is clustering membership, that I can activate or not. So if I click OK, there we go. I have my memberships here. So this is a very basic way to display results because I didn't develop quite a lot my XLSTAT-R function. If I copy those and paste them here, cluster, I can already run statistics on my different individuals according to the clusters they belong to. So let me show you another more sophisticated version of this partitioning around medoids function, which is here. So we have many more results. We have 3 results. We have many more options, which can make things more convenient for the user. There it is. So if I take all of these, I also have my number of clusters. I can add observation labels here. Here I also have my metrics. Outputs, I have several outputs, and I have a chart. So I click OK. And here we go. I have my medoid summary in Excel. So what is the medoid observation of each of the 3 clusters? I have the cluster memberships of each of the observations that are associated to labels. And I have a chart that is coded in R, that is imported in Excel in the form of an EMF file. So how did I do this? I simply added a result here that I called within cluster dissimilarity average. In charts in XLSTAT-R, you can either code your charts in XLSTAT or in R. Here I coded it in R. You can export them in PNG or in EMF. You can configure the width and the height. And at last, in the rplot code attribute, you can enter the code that generates the charts. And of course, this code, you can customize it as you want. If you want to add another line of code, you can put a semicolon and add, I don't know, points or other things. So it's very convenient. So we've gone through all the steps to develop an XLSTAT-R procedure. So I really hope you liked it. And now, just before switching to questions, me show you this. So the XLSTAT based solution includes XLSTAT-R. The XLSTAT based solution is the solution that includes the 100 essential statistical features in XLSTAT, and it also includes XLSTAT-R. So it can be acquired at $50 for students, $165 for academics, and $295 for companies on a yearly basis. So do not hesitate to click here to download the 30-day free trial in which you can play around with XLSTAT-R, and here to get started with XLSTAT-R. So let me see your questions. R is awesome, but not the fastest piece of software. How this integration in terms of speed? Actually, in terms of speed, it's the R engine that runs. So the speed is limited by the speed of R. In your XML demonstration, it seems you have access to all options arguments of the R functions we're calling through XLSTAT. Is this correct? Yes. Command line, can we call R functions using command line in XLSTAT? Well, no, this is not the goal of XLSTAT-R. XLSTAT-R is really intended to develop these functionalities that help people who do not want to learn how to code access complex or simple R features. But can we work with all R packages? Well, as long as you are, as the outputs you are producing are in the form of data frames, and as long as the inputs are not super complicated, yes, you can. Can XLSTAT-R make use of R GPU processing packages or other parallel processing packages to improve speed? Technically, yes. If you call the R engine and you write R code that calls specific GPUs, normally I don't see why it shouldn't work. I have never tried this myself, but I don't see why this shouldn't work. And do you have any other questions? Well, thank you all for attending. You will just be asked to fill out a survey to tell me what you think about XLSTAT-R and what are the things that could be improved and everything. Yeah, I have one last question. Can XLSTAT be used with R Shiny? Today, no, unfortunately not. We are only able to call the basic R engine, and now with no connection to Shiny. But maybe someday, I don't know. Thank you everyone for attending. I hope I'll have the chance to talk to you again soon. And I wish you a very nice day. Bye-bye.